The next topic in the course is everybody's favorite, and I do mean that with some bit of sarcasm, and that's how to graph inequalities. So far we've talked about lines. We've talked about equations that just go in one direction. There's no squiggles in them. There's no up and down to it at all, and it's just a straight line, and that's it. The next step in understanding how to graph things is to graph inequalities. And really, if you know how to graph the equation of a line, graphing an inequality is really no sweat. So without talking about it forever, let's just dive into a few examples, and I think you'll get the idea. What if you had an inequality that looks something like y is greater than or equal to 3 minus x? There's a few things I want to say about this, but I think in order to say them, we need to work through an example first, and then we can move on from there. First thing I want you to do when you're confronted with this is totally ignore this symbol right here. This means greater than or equal to, but for right now I want you to pretend it just says equal to. I don't want you to even contemplate the fact that we're working on an inequality here. So let's do that. Let's draw our axes like we always do. Okay? We'll draw them like this. This is x, this is y. Okay? Another way to write this equation is y is greater than or equal to negative x plus 3. I retained the symbol here, although I want you to kind of forget about it. All I did was flip the order of these two things because we generally have been working problems with the x written first and the y-intercept second. So, how do you work this problem? Let's go ahead and make some marks on our board like this. So this goes 1, 2, 3, 4, 1, 2, 3, 4, 5 like that. Let's plot this as if it were a line. The y-intercept is 3. 1, 2, 3. So I'll put a dot there. Easy so far. The slope is negative 1, which remember, the slope is rise over run. It's negative, so I'm going to rise down to the bottom and go over 1 because the slope is negative. I'm going to put a dot here. Now, if this were just a simple equation of a line, I would draw the line and that would be it. So let's pretend that we're doing that. Okay? Now we've got our line drawn. Cool. But this is not the equation of a line. This is an inequality. What you do is you pretend there's an equal sign there, you draw your line, and then you have to shade some of this graph. And I'm going to shade the proper part and I'm going to explain it to you. The solution to this problem is everything above this line to be shaded. You have to pretend here that that's a nice shade there. Okay? So the solution, or the graph of this, is this line and everything above it, all on up to infinity, all up over here, all up over here. Nothing down here is included in this graph. And the reason that kind of makes sense is, what I'm saying when I say y is greater than or equal to this is, what I'm saying is, if I draw a boundary, what this represents is everything greater than or equal to this set of points called a line. So everything above it, greater than, because bigger numbers in y go up like this. So it's everything greater than. So all you need to do is draw your line, figure out if it says greater than or less than, and then shade appropriately. If this had said less than or equal to, well then I would have shaded everything below, because it would have been everything below less than on that line. Okay? Let's do a couple more examples, and I think things will become clear. And I also want you to notice that this line here, I drew it as a solid line. And I will explain why I did that in a second when we get to the next problem, actually. But I want you to kind of keep track that that was no accident. Let's say